Welcome back to the cooking show, and yeah, we did that one, right? So what we're doing today in the second part is we're going to do the same as what we did in the first place, but now when we pick out something, we're not going to replace it, and then we're going to look at those probabilities. So what's the probability of picking out a potato, and this is a genuine question, so we're not going to replace. What's the probability of picking out a potato, not replacing it, and picking out another potato? Well, that doesn't really make sense. That must be zero. So it does make sense, but the probability is zero because can't pick out a potato, not replace it, and then pick out another potato. Try to draw your tree diagram. Let's just see how you go. And hit pause here. And how did you do on how did you do on just trying to draw the tree diagram by yourself? And just to see, maybe you're going, yeah, I got it, so I'm basically just skipping through the rest, or didn't know where to start. So where to start? We've got three options. Initial scenario looks the same as last time. Apple, onion, potato. We've got 3 apples out of 6 things altogether. We've got 2 onions out of 6 things altogether. 1 potato out of 6 things. Starting point looks the same. Next point looks similar as well, because if we pick out an apple, don't replace it, and look from there. What's the probability? What items do we have on the table? Well, we've got apples, onions, and potatoes. Apples, onions, and potatoes. Look at our probabilities though. How many things do we have left now on the table? Well, yeah, we've only got 5. So we got everything is going to be over 5 this time instead of over 6 because they're 5 things. What's the probability of picking out an apple? Well, 2 apples, 5 things, 2 out of 5. What's the probability of picking out an onion? 2 onions, 5 things. So we're as likely in the second scenario now to pick out an onion as we are an apple because, well, they're 2 apples, 2 onions. Probability of picking out a potato? Just the 1 potato there out of the 5 things. Cool. So, pause. How do you get on filling in the rest of the diagram now? Okay, I wish that I could just see and get that response live. So let's take this. I'm going to do this over there, there, and there. I haven't planned my tree diagram well enough with space, but so what? If I pick out, so we pick out an onion first time. Whoopsie. And try and break everything in the meantime. I don't know how that's going to come out. So we picked out a onion and we're not replacing it. So our thing's vaguely over here. Oh, there we go. There are our fruits. Okay, so there are fruits. So we pick out our onion, and I'm going to look back at the video and you'll probably see the green screen there, and we don't replace it. So we picked out the onion, don't replace it. What's the probability? We've still got apples, onions, and potatoes. So we've still got apples, onions, and potatoes. There's still 5 things, so all our things are going to be over 5, over 5. And we can look, how many apples? 3 apples. How many onions? Just the 1. How many potatoes? 1. In other words, let's pause and see where we're at. We randomly picked out an onion. Then we went on our second pick. This is this red part in the middle. We've got an onion. Now we're very likely, 3 out of 5, to pick out an apple randomly because there's so many of them. We're as likely to pick out an onion as a potato in our soup or whatever we're making. Okay, so how are we looking now? Can you fill in the last bit of our tree diagram? Well, let's see. Pick out a potato. Pick out potato. Cool. What options do we have to pick from? Well, we've only got apples and onions now. So we've got apples and onions. There's no point even drawing the arm for potatoes because you could if you wanted to. So you could draw potatoes and say that's a 0. Either way, I would not draw it because there's no probability. So we got apples. Still got 5 things on the table. 5 things. 5 things. What's the probability? Well, there are 2 onions, 3 apples. Well, let's start with apples. 3 apples, 2 onions. So let's look at our tree diagram to answer that very first question. What's the probability of picking out 2 potatoes? Well, we'd have to get a potato, and then so the probability is 0. There's no probability that we can pick out a potato, use it in our stir fry, and then pick out another potato. Potato is gone. Okay, what's the probability of picking out, like we did last time? Last time we looked at it and said, what's the probability of picking out 2 apples? So we're going to pick out an apple, and then on the second go, we're going to pick out another apple. Well, let's look at our tree diagram and say we need to pick out an apple, and then we need to pick out an apple. So we know that we multiply when we go along the branches. So we've got 3 over 6 times 2 out of 5. Well, that's 6 out of 30, which, wow, does it really cancel that well? 3 times 2 is 6, 6 times 5 is 30, which is a fifth. Okay, so we've got a fifth. All right, that was a half. So a fifth chance of picking out, i.e. 20% chance of picking out 2 apples. And we could look at something more interesting, more difficult, I guess, more complicated. Last time we said, what's the probability of picking out at least 1 onion? And now we're going to have some work to do. What is the probability of picking out at least 1 onion? And more so than that, how are you going to figure this out? So what we're going to do now is say, great stuff, let's pick out at least 1 and let's go through it in. If we pick out an apple in the first go, if we pick out an apple, just like last time, we're not replacing though this time, but it doesn't matter. Like last time, our second pick has to be an onion. So to start with, we must be going 2 out of 6. So this is for our at least 1 onion times 2 over 5. Then we need to add. We could pick out an onion on the first go, and then it doesn't matter what we do after that. So we've just got that 2 over 6. Plus, if we picked out a potato, so if we picked out an onion the first time, it doesn't matter what we do. If we pick out a potato, then our second pick has to be an onion. So we're going to go down here, we're going to go down here and say 1 over 6 times 2 over 5 and figure that out. This time I'm going to do it on the calculator. And the time I do that, you should finish it as well. And check your answer. So, question is, review. How is that? How is that tree diagram feeling for you now? 2 over 6 times 2 over 5 plus 2 over 6 plus 1 over 6 times 2 over 5. I think I might be quicker not on the calculator. 8 over 15. So it's more than half a chance that you're going to pick out 2 onions. How did that compare to earlier? 8 out of 15. Let's put that as a percentage. S to D times 100. 53%. Earlier, 56%. Very interesting. So if you don't replace, then it's more likely that you're going to pick out at least 1 onion.